Okay. So
Dheeraj, I have a quick question. In Hadoop distributed system, how much flexible to add nodes or remove nodes based on the needs?
very good. So it's pretty flexible. So by adding and removal of the nodes are very flexible. It's like you have to make your node ready. Let's say you have 100 nodes, right? So first you have to, if you are adding 20 more nodes, so you have to make your nodes ready. Like you just have to bring your OS at the same level, Java at the same level, all those things. And then once you have all of that, just adding and deploying of them is just maybe 3 or 4 steps, right? And the nodes will be added to your cluster. So it won't take more than, let's say, maybe 2 or 3 hours of work to add or delete a node. It's not more than that.
And for removal?
Yeah, addition of removal both is not very complex and it's not very time consuming. Removal also you have to first mark the node as like you are not going to use it. So once you mark them node, so Hadoop will not put all those data in those and existing data will be replicated somewhere else and then you can remove the node. So addition and removal both can be very easily done and it's very, very flexible. You can remove the node anytime. There is no issue with it. Okay, so that's also very good. Let's say today you thought like, okay, I'll be using 100 nodes, but tomorrow you don't have need. So you can remove the 10, 20 nodes and you can use it for some other purpose. So it's very flexible with addition and removal of nodes. Very, very flexible.
Okay, thanks, Dheeraj.
All right, very good. So let's talk about this particular slide where we're discussing the traditional database versus Hadoop. Okay. Now, traditional system, what happens if some of you are from C++ or from the Java or any other uh, programming model? So usually what happens is you will be having some database, right? We have to write some programs which is connected to that database, pulling out the data where the program is running. Right? Let's say you have application server and you have a database server. So the application program will be connecting to a database server. It will be pulling out whatever data it needs, and then you do whatever you want to do with the data, right? That's what a traditional program works. Any traditional program will be working like that only. So data is sent to the program. That's what a traditional system says, right? You connect, you get the data towards the program, and then you perform some computation or whatever we want. Now, in Hadoop, it's just the opposite. And this fundamental difference is the way all the distributed computing is working nowadays. So it's very important to understand the traditional versus the Hadoop. In traditional, we are getting the data towards the computation, but in the Hadoop, we are moving the computation towards the data. Okay. See, over here, we are getting the data towards the computation, but in Hadoop, what we're doing, we are just doing just the opposite. The computation logic, we are moving towards the data.
So, Dheeraj, for computation, from where we are getting the data in Hadoop? Then?
So, computation is a program, right? So, let's say you have a Java program or any other program. So usually, if you write a Java program, you'll be writing some database connectors which is pulling out the data, right? But in this, you have to write a program in a way that it assumes your data is present locally. And once you run that program on those nodes, it will process the data which is considering it is present in the same node itself. It's just the opposite. You are not getting any data towards the program, but your program is getting moved to the nodes where the data is already residing.
Can we say like that from program we are executing some command, and whatever the small cluster or parallel machine is there where data is available, just pulling all the data as per requirement. Is it like that?
No, we are not pulling any data. See, you write a program. Okay, you're not writing different small program. You're writing a program. That program will be run on multiple nodes wherever your data is present. So
Okay.
say for example, there is a program which is let's take a simple example.
No, does it mean like we are pushing the single program, I mean, multiple copies of the same program to different data?
Absolutely, that's what we are doing. Multiple copies of the same program is getting pushed to multiple nodes wherever the data is present. Absolutely, exactly, that's what is happening. Okay, so if you really think, like, if you want to have an analogy, so let's say, how does a human eat the food? So human brings the food towards its mouth, right? And why? Because the food which a human eat is not very huge, right? So it's limited quantity, so human brain can easily bring that food towards the mouth and it can eat. So similar thing over here also. The traditional system, because they don't deal with a huge amount of the data, they can bring the data towards wherever the program is consuming, right? Just on the other hand side, let's say tiger. So tiger's food intake will be much higher than a human's intake, right? The tiger has to bring its mouth towards the food because it has to eat a lot of food. So similarly, if we have to process lot of data, terabytes of the data, I cannot bring terabytes of the data to some application server, right? It's never going to work, right? You cannot bring 100 terabyte to some application server. So what will you do when you have to bring the computation towards the data, like the way line goes towards the food? We have to make our program to go towards the data and then process it over there wherever it is residing. So it's very costly to move huge amount of the data towards the program. That's why you move your program towards the data. And how do you move it? Let's say there are 100 nodes and you have to run a program on 100 nodes. So what I will do, I will make 100 copy of the same program and I will push to each of the node. And since my program is pushed to each of the node, all of them will run like running on the individual servers, right? So is this concept clear? Because that's a very fundamental difference between Hadoop versus a
Yeah,
traditional
it's
data.
clear.
All right, perfect.
Hi, Dheeraj.
Hello. Yeah.
Yeah, there is small doubt over here. Here we are talking about nodes. The one single node means a single machine, right, where the data is present.
Yes. Yeah. One node is one machine where data is present. That's your right.
Yeah, thank you, Dheeraj.
Adhiraj, one question.
Yeah.
If we are pushing the 100 programs on the 100 different nodes,
Hmm.
so the output will be the 100.
Very good. Yes, it will be 100.
Okay, so how will we aggregate all these 100 outputs? Because we need only one output, right? Not 100.
Yeah, very good. All of your doubts are really outstanding and superb doubts. Outstanding. So, see, that's a great question. Okay, if you are running 100 programs, you will be getting 100 copies, but you need only one copy. Very good. So, we have to have somebody who is accumulating all of those 100 intermediate outputs and then combining and then creating some outputs, right? So, all of that is done within the Hadoop itself. So all that accumulation and then getting all the outputs of 100 nodes and uh, storing it some particular output folder, it's all happening within the loop. And we'll get more clarity once we talk about the MapReduce. So all of these is related with the MapReduce concepts.
But there is, suppose in the traditional system, only one server is doing that work, right? But here, the 100 servers are doing the same work.
Hmm.
The computation is 100 times, right? Because one person should be busy, but here 100% will be busy for doing the same task.
Not the same
So,
task. Yeah, same task.
because
You are right, but on different data. That's correct.
but the processing power will get increased, right? Because the 100 persons are working on the same thing.
Yes. Yes. It will get increased 100 times. That is true. That's what we want.
But then the complexity, how we will differentiate the complexity of traditional system and the Hadoop then?
Yeah. So that's where comes the Hadoop. So if you really think of this, you are talking about this problem, right? High programming complexity. So
Yes, yes.
if your program is running on one computer, you can go and check their logs and find out, okay, this is the issue. But if your program is running on 100 nodes, how you will know whether it is failing, working, not working, what is happening, right? So definitely the higher complexity is there. And to solve that problem, the Hadoop is there. So Hadoop takes care of doing all of those things. So Hadoop is responsible to distribute your work, it is responsible to collect your intermediate output, it is responsible for restarting if any jobs have failed, it is responsible to monitor if it is really working or not, it is responsible to find whether it is hanged or not. Everything what you can think of, it's all done within the framework itself.
Okay. Is there any way so that suppose in one node the output will be much faster compared to the all 99, right? So is there any way we can store that output only and stop processing of all 99 nodes so that we can save the complexity of those 99 nodes?
I didn't get, so how I didn't get the question, so can you repeat that one more time?
Suppose we are running we're running one program, right, on the all 100 nodes. So suppose for the first node we are getting the output faster than all 99 nodes.
Okay, 1 second. I think, okay. See, all 100 are not doing the same job. Okay, let's take an example. You have, let's say you have, okay, let's say you have 100 lines of data file, for example, okay? 100 lines
Okay.
is 100 records in a data file. 100 lines in let's say this is present in file one, okay? Okay, what I'm going to do is, it's not like this 100 line is going to one particular node and we are working. So what I'm going to do, going to do two lines in each node. So let's say two lines it go and another two lines it go to node number 2. Okay, and the next two lines it go to node number 3. Right, so in this way it will go, and then total how many nodes will be required to process this? How many nodes I need if I put two lines in one? So total how many nodes are required? 50 nodes, right? 50 nodes. So what I'm going to do is, I'm going to run the processing on 50 nodes. So unless and until all of the 50 nodes produce their output, I will not be able to process the 100 lines, right?
Okay, okay. So the data will be divided equally or based on the logic.
No, no, no.
So that like
It will be divided based on there is a concept of the block size. Now we'll cover that while we talk about the HDFS, but it will be divided equally. You can think it will be divided equally.
okay, okay.
We are not going to cross-check the capability of that particular node.
But capability, like you are thinking, like if this one is doing the faster,
Right.
if this one is faster than this, how it matters, right? If this will be fast, then let's say this takes, let's take this example, right? It took 1 millisecond. It took 1 millisecond, okay? It took 1 millisecond, and this one took 2 milliseconds, and this one took 1 millisecond, for example, right? So we are saying that this one is slower than other two. So how it really matters, because if you process 100 lines, it will take maybe 1 or 2 minutes, but over here you are getting everything in milliseconds.
In this way, actually, the time is getting doubled for node 2 for the same set of lines. So instead of having numbers of lines on node 2, we can distribute it among node 1 and node 3. So the
Yeah,
output will be quite fast in that way, right?
good. So that's a good concept, and so this will happen only when this node is slow than other two. Right, so let's say this one is having some network issue or some hardware issue, whatever issue, if this is running slower than the other two, so there is a process which, there is a concept which is known as, uh, 1 second, let me mute you, sorry about it, okay. So if this node 2 is behaving slower than the other two, so what Hadoop will do is it is going to speculative execution, and it's one of the interview question also, speculative execution. So what it is going to do is going to speculate how much of the time it is taking. So once it find out like this is taking more than usual, so if the average is 1 second and this one is taking more than this, so what it's going to do, it will start another process. So let's say it will this two line, it will start a parallel job on node number 4, or let's say node number 51 as well. Okay, and if node number 51 is giving me in 1 millisecond, so this output will be considered and this will be killed after 1 millisecond, right? So this is now a speculative. So Hadoop internally will take care of speculating what is the average time required and which nodes are behaving slowly than the average, and based on that it will make a decision to start the same computation on another node as well. So we don't, as a developer, you don't have to think all of this. All you need to do is you have to enable speculative execution. Once you enable it, it will take care. If you disable it, it will not do all of that. Okay.
Okay, Dheeraj, I have one more question. As we are saying that in this particular thing, we are moving the computation to the data. Right. So the program which is going to be distributed among all the nodes will be compiled already and will be executable, or it will work as an interpreter for each of the nodes?
It's okay. So it has to be an executable.
Okay. So it will be compiled on one of the node only, then it will get distributed and it will work like that, or
Yes.
whenever it is going to. Okay. Okay.
Yes. Okay.
Yeah.
Very good.